Hi, welcome again. This is lecture 6 in our series. This one we're actually only going to use the placement value, and what I'm going to do now is to show you something similar to what we did with the solar leap year cycle, where we showed that the whole value of 3 years and leap year equaled exactly the number of days in those 4 years. The question I asked when I had done that and discovered that was, is it possible to do that with the Jewish lunar leap year cycle? Now, the lunar cycle in the Jewish calendar is actually 19 years, and why that is because when it comes to the festivals, for example, the festival of Passover, Pesach in Hebrew, is called in the Torah and the 5 books of Moses, it's called the spring festival, Chag HaAviv. It's called a spring festival, and therefore the rabbis learned that Pesach, Passover, must occur during the spring season. It is a harvest festival after all. In fact, all the 3 foot festivals, Pesach, Shavuot, which is called Pentecost in English, and Sukkot, Tabernacles, they are all concerned with the harvest or ingathering. The Sukkot is the ingathering of the grain before the rains come, and so they are seasonal festivals. They represent a part or a section of the season. As such, since Pesach has to occur in spring, and unlike the Islamic calendar, which is also lunar, where, for example, the month of Ramadan will be a different part of the year as it goes by, and it could be in spring, winter, summer. It will drift through the year, because the Jewish calendar has to be at the certain seasons. So we have to add an extra month every certain number of years. The normal year has 12 months, and the leap year, the intercalary year is a better term for it, is when we add one more month, so there'll be 13 months. The month that is added is the month of Adar, which in the Torah, the month of Nisan was the month in which the Israelites were brought out from Egypt. The exodus from Egypt took place in the month of Nisan, and that is called the first month of the year. Although we celebrate the New Year in Tishri, which is actually called the 7th month in the Torah, whereas Nisan is called the first month. So I'm not going to go into why that is the case. Well, we actually have 4 New Years in the Jewish calendar, but putting that aside, we now have to find out how does the Jewish lunar year catch up with the solar year, which is 365 days or 366 days. So let's take a pen. The 9-year cycle has the following. We have 19 years. I'm going to write down 1 to 19 to make this sort of simple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and we'll do it down here, 14, 15, 16, 17, 18, and 19. Now the times when it's a leap year are on the 3rd year, they're on the 6th year, and then we only have 1 year of a normal year, and then we split another 2 years, and then 11th, and then it goes to 14, and then it goes to 16, then it goes to 17, 2 years, and then it goes to 19. So what we have there, we'll use another colour for this, we have 2 years, normal years, 1 leap year, I'll put an L there, then we have 2 years, and then 1 year, sorry, we have a leap year, and then 1 year, and then a leap year, and then 2, a leap year, 2, a leap year, 2, a leap year, 1, and then a leap year. Now, it was a man called Hillel II who, in the year 358 CE, get this right, because I'm not very good on my CEs, or as a common era. Common era is what the Jews call AD. We call it common era from that date. So in that year, he saw there was a problem, because before Hillel came up with this whole calculation, it was done by the new moon, for example, was done by witnesses, and the year was inculcated by the Sanhedrin, or by any leading rabbinical authorities at the time. But people were spreading around the world, and people needed a calculation, and he came up with a formula which is used to this day and is very accurate, with little need to change it. So we are still using his formula, and we have this 19-year cycle. So if we now look at the actual months involved here, we have 7, 1, 2, 3, 4, 5, 6, 7. We have 7 years of 13, that's the leap year, and we have 12, making up to 19, of 12 months, and that is 91, and that is 144, making a total of 235 months. So we have 235 months in those 19 years, of which 7 years are of 30 months and 12 years are of 12 months. Now, we're going to show you some interesting things. The first thing I'm going to show you is these numbers here, 2, 2, 1, 2, 2, 2, 1. If we write those down, their values, 2 equals 58, and 1 equals 34. We've done those before. That's like A and B, the large values. But 1, using placement values, PV is 34, and 2 is 58. So I've got 1, 2, 3, 4, 5 2s. So I've got 5 times 58. And I'm going to add to that 1, 2. Just 2 lots of 1. Plus 2 times 34. If I work that out, I'll get 358. If you want to just check that out, that's 5 times 8 is 40. Write it down here. 5 times 5 is 25 plus 4 is 290. If I come over here, 2 times 4 is 8. 2 times 3 is 6. And if I add those together, 290 plus 68 equals 358. In other words, this pattern 2, 2, 1, 2, 2, 2, 1 gives me the same number as the year in which Hillel actually calculated this. Next, we're going to look at these numbers here. We're going to look at 91. We're going to look at what 91 is as a number. We're going to work out 91 and calculate what that is. That's 91. 90 is 87 actually, and 1 is 34. 87, 91, 121. And 144, we're going to work this as 100, and I'll put it short, 44. And if you work that out, 144, you'll find it equals 237. And if we add those two numbers together, 121 and 237, you'll find it equals to 358. Very strange, isn't it? So, by the way, this 235 months is connected to the number of days in the solar leap year cycle, because we said, now I'm going to see which I can rub off at the moment. No more room left. I can get rid of Hillel. I'm afraid, well, not really. He's gone a long time ago, but we'll get rid of him at the moment. We need some space. We said that the number of days in the 4 years of the leap year was 1,461. Remember, that was the whole value of 3 years plus leap year. So this is the number of days. If I was to write this, remember this is like time, and we're dealing with time now. You know, when it comes to some time and dates, we call these numbers different. For example, when it comes to the time on the clock, we say like it's 4:50. So we have the 4 and then the 50. Here we have dates. If you ever have a date, you'll say like it's 1461. So instead of saying 1,461, we're going to call this 1461. And it just so happens, if you work that out, 14 is 104, 60 is 52, 72, 77, 97, just remember that one, and 34 is 1. If I add that all together, I will get 8 and 7 is 15, 9 and 3 and 1 is 13, and 1 and 1 is 235. So I actually get, when I take that number and read it as 1461, I get 235, which is 235 months in the 19-year lunar leap year cycle. Okay, well, let's rub that one off. Nothing is by chance, and there's particular reasons for that as well. If you want to know a little bit more about all these, there's a book that I wrote called Gimel Tammuz. Gimel Tammuz is the third of the month of Tammuz. The month of Tammuz is one of the Jewish months on the lunar calendar, and it was the day in which Joshua asked God to still the sun and the moon, so they wouldn't move in the sky. And I believe that was at a time of a partial eclipse. I put that on my front cover here. I believe it was a partial eclipse. There was a crescent in the sky, and in fact, at the back of this book, I give 2 possible scientific scenarios of how that could have happened as far as the Earth is concerned, because it would have happened if the Earth was to have slowed down so much that it didn't spin more than the speed at which the moon was travelling around. So there would have been like an eclipse in the sky for a much longer period of time than is normal. And I explained how the Earth could have slowed down its spin around its axis for a period of time. It would have been rather spectacular. I don't know why they haven't yet made a film of this, because it's really quite interesting. But you can read about that in this book if you're interested. I have in this book a few appendices, and one of them is on the solar year, which the solar leap year cycle, which I've explained in a previous lecture, and the other I've got another appendix on the lunar cycle, which I'm giving you some information from today. So this is called Gimel Tammuz. It will be written in English. I think it's on Amazon. I'll have to check that up soon. So now we're going to go on to what these something rather similar to what is done in the Hebrew. So excuse me if I just. So what we have 7 years. I'm going to rub this off as well. We have 7 years which are called leap years, but better turned into calorie years, and we have 12 ordinary years. Now if I write those words down, I'm going to write 7 intercalary years. I'm going to check my spelling. I'm a bit dyslexic, so I do get things wrong. So intercalary years, that's right. And 7 intercalary. No, we've done that. We now have 12 ordinary years. Okay, so now if I was to work that out and the placement value of 7 intercalary years using the placement value, S is 19, E is 5 all the way, and you add all that together, you will get 259. That's PV value. And if I work out 12 ordinary years, again T is 20, 23 all the way, and I will get 259 placement value. So, interestingly enough, we have 7 intercalary years balancing out the 12 ordinary years. And one more, very interesting one here. So, okay, that's interesting. Why that is, not sure, but why there is this balance between the two. But it's an insight. But what is interesting, if you take the words the 19 years cycle, which is what this is, the 19 years cycle, and I work that out, I will get 235, which is exactly the number of months in those 19 years. So that's the gematria that I think is very similar to the one that we've got in English, where we've got 3 years, leap years, gives you a number 1461, which is the number of days in those 4 years. The 19 year cycle gives you a number 235, which is the number of months in those 19 years. I thought that's very interesting that you could do something very similar to the Hebrew and to the English. And that brings us to an end of that particular topic. There is one other gematria which I missed out, which is the 12 regular years. In other words, it's regular rather than ordinary. So 12 regular years equals 237, which is the same as 144, which we had before. But you can see that there's patterns and interconnections that exist, that nothing seems to be by chance. There's something, the things fit in a way which is almost impossible for man to think about on their own. I don't think Hillel knew about England, let alone about English as a language. So he didn't have that in mind. He didn't have these words in mind when he did it. So this is something which is deep in his subconscious. Somewhere there is a pattern that history is producing things like this. It's something we can talk about later on as well, when we really look into why English has become a very universal language. And I'll discuss more deeply about the meaning of gematria and why it exists. That will all come together. Okay, thank you very much for listening to Lecture 6. Please listen to the other ones if you haven't done so, and give me a like and share these videos. If you're interested in this book, I will check tomorrow to see if I've got it online. It goes through the Battle of Joshua with against the kings that came against him. He was meant to be saving the city of Gibeon, and Gibeon wasn't a Jewish Israeli city. They were part of the Canaanite nation, and they came up to Joshua and they made a peace treaty with him in a deceptive way. You can read about it in the book of Joshua. It's in chapter 10 of the book of Joshua. They came, and then the other kings in Adoni-Sedek was the particularly ringleader. He got other kings to go to war against Gibeon, and Gibeon sent out messengers to Joshua again to say that they were being attacked, and then Joshua goes and to attack or to protect Gibeon and attack the other nations there, which they win and slaughter. And it's at that point that Joshua needs to have more time for the battle, and therefore asks for the sun to stop still and for the moon. An interesting story, very well worth reading in the Bible itself. Have a good day, and we'll see you for lecture 7. Be well.